Hi. In this short video I'm going to talk about representation and equations. This is probably, in terms of pre-calculus and for any math class, this is an absolutely essential skills. You might as well, this section could equally well be called analytic geometry or coordinates or something like that. What I've noticed is that you have a hard time grasping the concept of coordinates. And this, I don't know why this is. If you can tell me, I would be very happy. So, for instance, what are the coordinates on the x-axis? The coordinates, an arbitrary point on the x-axis looks like this: x, comma, 0. Any point on the x-axis looks like this for some x. What about points on the y-axis? What do points on the y-axis look like? Well, an arbitrary point on the y-axis here looks like, well, it's got 0x coordinate, and otherwise it can have any y value that you want. So this is how you coordinatize or parameterize values on the x or the y-axis. If you are given an arbitrary function and the equation of that function is y equals f of x, then an arbitrary point on this function, say here, will have coordinates x, comma, f of x. Using this kind of coordinate technique is the way that you set up equations. So if we're looking for the value of the function that's closest to the origin, then what do? Well, that's the intersection of what is that? That's the intersection of, say, this graph with concentric circles at the origin. And the first circle to hit that puppy, those are the closest points, right? That's the deal. So the intersection is going to be an equation. Circle equals function. And how do we do that? Well, we use these coordinates, and that's how we set stuff up. So I'm going to clear the boards here, and then we're going to start with a concrete problem. The same problem gives students fits over and over and over again. So the key to all these problems is drawing coordinates, writing down an equation, and solving an equation. Okay? So here's a problem to focus our attention. The question is, what point on the x-axis is 2 units from the point 1, 1? So let's start by drawing a picture. So here's our point 1, 1. 1 and 1. The question is, what point on the x-axis is 2 units from 1, 1? Okay? So that means really what we're looking at is we're looking at the intersection of a circle of radius 2, which might look something like that. Okay. This, maybe this. These 2 points might satisfy those conditions. Now, to figure that out for sure, so that's just a sketch and a kind of an idea. So let's work out some equations. Okay. So the first thing to do is to figure out what does an arbitrary coordinate on the x-axis look like? Well, it looks like this. That's what it looks like. Okay. So let's look at the distance between x, 0 and 1, 1. Okay. So the distance squared is going to be equal to x minus 1 squared plus 1 squared. Okay? And what is it that we want the distance to be? We want it to be 2 units, so 2 squared is 4. So at the end of the day, our equation is 4 is equal to x squared minus 2x plus 1 plus 1. Okay, so now it's just a matter of algebra. Okay, now we're going to simplify this, and we've got a quadratic equation to solve. Okay, so let's put that together. What we're going to get is we're going to get this equation up top. We're going to get x squared minus 2x minus 2 equals 0. Okay, this is the quadratic equation that we have to solve. Now I'm going to minimize this, and we're going to start on the solution. So we let a equals 1, b equals minus 2, c equals minus 2, and so our roots are 2 plus or minus the square root of 4 plus 4 over 2. Right? We got b squared minus 4a times c. Well, actually, so we should have an 8 here. This should be an 8. So that gives us what? This gives us r equals 1 plus or minus, what do we got here? Square root of 12 over 2. Okay, square root of 12. Let's see what we got there. That's going to give us 2 square roots of 3 over 2. So our solutions are r equals 1 plus or minus square root of 3. Okay, so we have one solution, which is what? 1 plus square root of 3 comma 0, and our other solution is 1 minus square root of 3 comma 0. Okay, these are our two solutions, and if we're good at our job, we will check that these solutions give us the correct distance of 2 from the point 1, 1. And this should be easy to check, because we can check exactly, so let's check here that the distance from 1, 1 to 1 plus square root 3, 0 is in fact 2. So 1 minus 1 plus square root 3, that's going to give us square root 3 squared plus 1 squared. So square root 3 squared is 3 plus 1 is 4. Square root of 4 is indeed 2. So that tells us that this point is in fact how far we need it to be. And you can check that this point will give us the exact same thing, because 1 minus square root 3 is going to be plus square root 3 squared, gives us the exact same distance. So we have found 2 points, we have checked that they are the correct answer, we've drawn a picture, and the key part was representing the solution as all the points on the x-axis of this particular form. So please learn how to represent coordinates, learn how to use variables, and you will never have a problem with these kinds of problems again. Okay, good luck, practice, bye-bye.